All right, so let's go through question 1 of intervention test 6. This is the one on changes of state and pressure volume equals constant. Let's go, question 1. Okay, so we've got to compare the student's apparatus. Big difference here is a data logger versus a thermometer. So let's have a look and let's see what advantages we can think of. So A makes it fair. Well, hopefully these are both fair tests. Weird, they say you can't, sometimes they say you can't use that, but then they're using it there. So anyway, I think they should both be fair tests. There's nothing there about the equipment that says they're not. Student B only measured categoric variables. Well, temperature isn't categoric, is it? It is, what would we call it? Like a spectrum of variables. Why can't I think of the name? This is embarrassing. Discrete. Continuous. It's a continuous variable. Temperature. Forgot the word. Continuous variable. It can take any value. It's not a category. So it's not going to be that one. So 2 advantages must be this one and this one. So high resolution and that makes sense, right? Let's see, why is it high resolution? Well, these only measure to the nearest degree, 74 or 75. This one is giving me higher resolution. It's giving me a decimal point. And then student B, yeah, if they glance at that thermometer, they might misread it. They might have a parallax error. So yeah, those are the 2 answers. They removed the thermometer every time they took a temperature reading. What type of error would this be? Well, it's really, really hard to kind of, if you imagine trying to reverse this, like remove this error. So you get the data and then you think, this data is wrong. Let's do some fancy like subtraction. Let's like minus a number or add a number or something to fix it. Can you do that? If you can, it's systematic. It's the same every time. Well, I don't think you can here. This is a random error, because it's impossible to know the effect of removing the thermometer each time. If it was taken out for longer, the temperature is going to change by a greater amount. It's really, really going to get complicated to try and undo that error. Okay, next one. What was the temperature decrease between 0 and 160? So what I would be looking for you to do here is kind of mark 0 and then mark 160. So each little square is worth 20. So 120, 140, 160 is right there. So I'm trying to find the change from there to there. So it looks to me like we're starting at 64 and we're going down to, now what is that? 55. So again, 55.2, 55.4, 55.6. So to work this out, I need to do 64, take away 55.6. And when I do that, I see that that's 8.4. Use figure 2 to determine the time taken for the steric acid to change from a liquid to a solid. Okay, so where is it changing from liquid to solid? It's this flat line along here. So fortunately, we've already got one of those points there. This is 160 seconds. And then it starts changing temperature again at 900 seconds. So basically, find the difference between those two. And that's going to be, is it 740, 840, 740? Why does that seem wrong in my head? No, I think it's good. Okay, find the energy transferred as this mass of steric acid changes from solid to liquid. And we're given the specific latent heat of fusion. Okay, so this is our L value. This is our M value. The equation is E equals mL. Weirdly not on the physics equation sheet. It was on the board though. 0.40 times 199,000. I need a calculator. I'm going to use my phone as a calculator. Don't tell anyone. 0.4 times 199,000. We get 79,600 joules. After 1200 seconds, the temperature continues to decrease. Explain why. Well, think about why anything changes temperature. If I have a cup of coffee in my classroom, no, I wouldn't. I would never have coffee in my classroom. But if I had a cup of coffee in a room, and let's say the coffee is at like 80 degrees, and the room is at 20 degrees, you all know that the coffee is going to cool down. What about if I had a really cold drink? So what about if I had something like a glass of lemonade with some ice cubes and stuff in it, and so it's really, really cold. It's lovely, lovely fresh glass of lemonade. And let's say that the temperature of this is only 10 degrees. What will happen to its temperature? Well, the 80-degree cup is going to cool down. The lemonade is going to warm up. And so what's going to happen here? We're going to see that the stearic acid is hotter, or the stearic acid temperature is higher than room temperature. Let's use bullet points. So stearic acid will cool down until it reaches room temperature. And at that point, we'll say that they're in thermal equilibrium. I'm not going to write that, but that's the technical name when two things have reached the same temperature, thermal equilibrium. Okay, cool. That's the end of question 1.